Okay, so we're going to show you today how you can scale up a RAG system into a big company by considering two main concerns, two main things. Firstly, the quality of the responses is crucial for our business because it impacts directly in the customer satisfaction. And secondly, our documentation should always be up to date because we have to deliver then new releases every time. So, in few weeks, in less than 2 months, we accomplished an MVP easily by creating a GenAI-based assistant in Microsoft Teams. So it's always available in smartphones, tablets, laptops, 24/7, answers in real time, and it's the framework communication for in our company. So Microsoft Teams is a very useful tool. It integrates directly with the Active Directory system and also links pretty well with Azure and all this stuff, okay, all this environment. So we created our first KPI by measuring the time that our insurance agents try to look up documentation in our storage system in order to answer to the clients. So our insurance agents are normally the proxies between the customers and the company. So normally, when a client wants to set a question or to ask something to our company, they normally go to insurance agent and they provide the answer. So they fetch documentation, they find in which piece of text within the documentation can find the answer, and so they answer finally. So we now try to save this time, and now the numbers are over there. So before we started, we collected some requirements. So we had only 2 months in order to create the first MVP. Okay, we finally, after this MVP, we scaled it up to a production with another most robust solution. But that was a previous requirement. They also wanted to have something conversational, something friendly. So Microsoft Teams was a very good approach in that way. And also very important, especially in our business, no hallucination. So we cannot make the answers up. So additional to this, we had some additional commitments in security and legal especially. And we, after the MVP, we should think about how we can scale it up to production, okay? Okay, now we are gonna show you and we are gonna provide you some tips on how we did it. But first of all, let me introduce you what is Santa Lucía. Santa Lucía is an insurance company. It's a very big one of the tops in Spain, very popular. We provide home insurances, life, savings, accidents, too many products, except health and except cars, okay? So anyway, we have a very long history, more than 100 years, and a very big staff, very large staff, okay? So we are located in Spain, so this is our offices in Madrid, fancy views. And so with this large, long history, you can imagine the volume of how much information and documentation we may have. So we have information regarding, or documentation regarding invoices, and too many products, and products along all those years. We have procedures to assist our clients, information regarding employees, clients, claims, and many, many reports alongside these years. So for this use case, we got focused only in products. And so we thought that was the best starting point because we have a lot of them. And we do not have only products of insurance, products of home insurance. We have several tiers, several packages, such as we can find the basic package, the full package, or the premium package with different coverages and so on. And in addition to that, we have home insurances from 2020, 2021, 2022, and so on and on. So there are slight differences among them, and we have to control all of them, okay? So our employees lose a very valuable time when they want to answer the clients and they want to find information, and sometimes when they want to compare some documents one to each other. So there are different coverages, and sometimes they need a fast answer or a rapid way to find out in which place they can find the answer. In addition to that, the language. The language is really, really complex. So it's full of legal terms, and sometimes it's quite complicated to understand what is the meaning of this article and so on. So I don't know you, but for me it's quite complicated, and I'm in this business. Okay, so the question at that point was, can we use a Gen AI solution to be more efficient in that way? Okay, so at that point, so internet was burning with this kind of solution, the RAG, the chatbots, and you can create it in less than 30 minutes. And in fact, you can do it, but you can do it in a Jupyter notebook, you can do it by your own with a few PDFs. Now we are working, so we want now to think in a big framework, in a big company. So can we deploy this solution into a big company with a proper life cycle of this model of it's an LLM ops mature enough or not? So important for us, the confidentiality of the documents or documentation. Is that secure? It is not. And very, very important for us that we call what we call the false positives. So if we provide bad answers, that is our main concern. If we provide bad answers, probably we are going to create rejection among the users. Because if the answer is not correct, so the customer satisfaction really have a very big impact. Okay, so at that point, we wonder if we can do it in an Azure and Databricks cloud, okay? In our platform, basically. Okay.
Thanks, Eduardo. So now I'm going to talk to you about the architecture behind this use case. But before that, I would like to provide you with some context about what was our previous situation before this use case. So in 2020, we created what we call our advanced analytics platform, which is mainly based on Azure and Databricks technologies. And it allows us to work with both BI and traditional AI use cases. So the point here is, was our architecture ready to onboard, to work, to develop Gen AI use cases? So short answer, yes, because Eduardo has told at the beginning of the talk, but long answer, here we go. Okay, now I'm going to focus on what was the main aspects that we consider when we designed our architecture. So, of course, there are several others, but I think this is the four main one. Privacy and security, scale up, CI/CD process, and the flexibility. So regarding the privacy and security, I think it was one of the biggest challenges we faced in this use case. So keep in mind, we are talking about our new technology. We're a Spanish company. We are not cutting edge. We sell policies. So, okay, we need to explain to our security and legal teams what is technology about and make sure they really understand. And keep in mind also that we're a Spanish company. We are under the GDPR, which is the European law regarding data protection, one of the strongest one. So if we're going to use ChatGPT, which was our first thoughts, our legal teams asked some question, okay, what is the data? It's outside the borders? Is our data used to enrich the models for OpenAI? Are our competitors accessing our information? So to be honest, we choose Azure OpenAI for that service, and it was really helpful because we had the support of Microsoft and Databricks engineers, security engineers, and to convince our security and legal teams on that aspect. And regarding the scalability, as Eduardo has mentioned before, we need to build things beyond a POC, not a notebook. We need to build something productive. So, and not only for improve our internal productivity, which is really good, but we keep in mind that we need to build something in the future that can we provide to our customers. So to build a massive use case. About the CI/CD process, okay, now the prompt is a new code, so people just code with just the English or the Spanish in our case. So if we want to use prompt, we needed to answer questions. So how is it going to be tested? What is the metric to improve? How can we avoid the prompt injection? So definitely we needed to evolve our MLOps framework to an LLMOps framework to achieve that. And about the flexibility, we need things to be deployable with flexibility. Eduardo told us at the beginning that we use Microsoft Teams as our corporate communication tool, so our agents also use it, but they are more familiar with Salesforce, which is the CRM tool of the company. So we need to deploy in both ways, Microsoft Teams and Salesforce. And of course, every day are coming up new models, new third-party LLM models, new frameworks, so we need to build something that makes it easy to integrate all this model to allow our developers to work with. Now, straight to the point, this is the beginning of our architecture. I'm going to show you our solution. This first stuff is the data ingestion section. So remember, we had a platform built on the top of Azure and Databricks technologies. We had also frameworks to onboard, to ingest information, which is a framework developed on Scala and Python. And we needed to evolve this to allow process PDF documents, tokenize information, get embeddings, and so on. And of course, deploy it to or store it into the vector stores. But keep in mind that we didn't allow our developers to access directly the Azure OpenAI API. Instead of that, we built something on Databricks model serving endpoints to create like an abstraction layer to do it. I will explain you later. So regarding the vector stores, you can see a couple of icons here. I don't know if you know what is the first icon. Have you heard about Azure Current Research Database? Hands up? No? Okay. This is a managed service of Azure. So we choose that because a simple reason. We have the goal to be live in less than 2 months. And our infrastructure team just feel more comfortable using a managed service of Azure. So it provides us good performance, good latencies, so why not? But we are now testing the Mosaic vector search one because it goes with our philosophy of keeping the things simple and reduce the complexity of our architecture. Now I want to zoom in on how we set up new third-party models on our platform. So if you remember, slide before, I said we need to build something that makes easy to integrate new models as they are coming up. So we create a simple project on Git. So we set up a JSON config file. You can set the provider, the credentials, the API, the endpoint, and so on. And we developed a CD process that just take all this information and deploy it in Databricks as an endpoint in the proper workspace and set up the permissions and so on. For the moment, we allow only Databricks marketplace models and Azure OpenAI, but in the future, who knows? Of course, this is like a proxy. I don't know if you heard about, of course, yes, the Mosaic AI Gateway, former MLflow AI Gateway, and so on. So this is a piece on our own that make our lives easier. And here you can see an example of this JSON file. You can see here the provider. We use Azure Key Vault to store the credentials and so on, and the API, and et cetera, et cetera. Okay, and this is the end-to-end RAG solution architect of this use case. So here the starting point was, okay, the vector stores, we store the embeddings, and we created a Python library which mainly use the Llama index framework. It processes the question of the agents that they ask, and it orchestrates several calls to Databricks endpoints and enrich the answer. And of course, to deploy it, we use a custom model, so we need to deploy as a PyFunc function on MLflow on Databricks. And if you remember, Eduardo told us at the beginning that we had a requirement which was, okay, we need to build something conversational. So we need to keep the context of the questions, the previous question and answer that the agents are asking to our chatbot. So to be honest, we went for the easiest way, which, okay, we will store it on Delta, and we will access through it through Databricks SQL serverless. It's not the best option, but it offers us good latency, and we can go live very, very fast. But just keep in mind, if we are going to scale to a massive use case, of course, we need to reevaluate this piece of code, because not only the latency, but also the costs. And for the second layer, okay, to go live in less than 2 months, we decided to start with Microsoft Teams because, okay, we didn't have experience deploying on Teams. So we find out a tool which is Copilot Studio, which allow us to create virtual chatbots. So you can call our models on Databricks, and you can set up or deploy on Microsoft Teams, Twilio, Facebook Messenger, and so on. So the proxy here was between Microsoft Teams and Databricks. We use Copilot Studio. And we call it the prototype path because, okay, with a few clicks, it's a drag and drop tool. We can test new features and make our agents validate if it works or not. And the production path that we call, which the previous one was also productive, but this is like the massive use cases. We have Salesforce on one side, which is the agent, the tool that our agents use in a daily day. So we replace Copilot Studio in this case with a microservice deployed on the top of OpenShift Container Platform. Now, I want to highlight what we thought was the essentials to scale a RAG, at least in our opinion. So the fact we have Mosaic AI model serving, former AI Gateway, and now I think they call Mosaic AI Gateway, was a key to success. Why? Because we can centralize all the concerns of security in one place, and we can manage it. And of course, we create an abstraction layer that allow our developers to test new models with the same API. So definitely, that was a milestone. Regarding the Databricks serverless, which actually is one of my best points on our architecture, we use it in a couple of ways. The one that I mentioned before, which is to use Databricks SQL Warehouse serverless, what's okay to get the historical information of our platform. But the massive use case of us is, okay, we used the model inference, the GPU model inference serverless. I don't know if you guys, but we're in Europe and we are facing several concerns to get more quota from our cloud provider. We need to fight each other to other customers to just please give us some GPUs to our use case. We're not so big as American companies. So we decided to delegate it to Databricks so we can take advantage of it. And regarding having a modular vector database allow us to, okay, we can swap from Azure Cognitive Search to Mosaic vector search and check if it works better or not. We are working on the integration of Llama index with vector search to reduce the complexity. So we have that facilities that make our architecture very, very modular.
So imagine now the following scenario. Okay, we have client. Oh, so can you read it properly? Okay. So imagine you have a client, and a client wants to know, so set a question regarding a veterinary care, and wants to know if he has to pay for the checkup or not because he has a home insurance. Okay. Once he puts this question into the RAG system tries to find in which documentation might be information regarding the veterinary care within the home insurance documents. Okay, once the RAG gets the information, elaborates an answer, and says, for instance, the home insurance policy does cover vet appointments and whatever, some details, okay? We may think that this answer is correct when it is not. That is what we call a false positive. So, it's a false positive because in reality, only the premium package does cover the veterinary care. Okay, this is just an example of a false positive. So if we do not write the word premium correctly in the answer, the client may think that his home insurance may covers the veterinary care, the checkpoint, so he has to pay. So if we do not clarify that previously, so it impacts directly in the customer satisfaction. Okay, so our concern is to mitigate or to reduce this ratio of false positives because it really compromises the success of the project. So here we are going to provide you some tips in order to mitigate this ratio, okay? Differently parts of the RAG system Let's take a look. Okay, here we have a piece of code, but before of that, jump into that, I'm gonna talk about the complex documents, complex PDFs. So we use normally, and we recommend to use GPT-4 Visio for image captioning, for transcribing complex documents, such as diagrams, 2 columns in a PDF, pictures, or sometimes watermark, okay? These kind of documents are pretty hard to transcribe, and it really works pretty amazingly. So once we have the text already transcribed, so we use Llama Index, okay? Llama Index is an alternative to LangChain, but in our experience, it works really, really good because of the metadata that we have here. So Llama Index tries always to split the documents into chunks, and each chunk is wrapped in a node, and each node has its own metadata. This metadata can contain different things. So in this scenario, we can contain a summary of the chunk of text, which is a shorter version of the content. We can have questions that can be answered within the text that you have here. So anytime that you set a question through the user interface, so for instance, I want to something, so probably this question is already here in this metadata part. So the embeddings is gonna get closer, and it's gonna fetch the best node to answer them. So very interesting, because only with few lines of code, you can create your own pipeline in order to create this metadata. Highly recommendable. So what else? The routing query engines. It's a very useful tool, because anytime you set a question, and I don't know, maybe you want to know anything regarding a report in the 2024, but you don't have this 2024 report still in the documentation, the repository, and it may answer according to the 2023 report. So it is also a false positive. The routing query engines ensures that it's gonna fetch the documentation you are asking for. For instance, you ask for a basic insurance, so it's gonna answer according to the PDF, which corresponds to the basic package, the basic tier. So here there is a piece of code creating or described by a natural-based description, and it's pretty easy to use. What else? We have the tool-based agents. We have now some agents in order to trigger some actions, to take some actions. For instance, anytime that somebody writes something badly or something interesting about the competitors or in our business, so we send an email afterwards, and we report it in order to take actions in a row, okay? What else? It's interesting to use memory. So I mean, the previous question that the people can set in the user interface. It allows us to narrow what are you thinking, what the client is thinking about exactly, and to answer much better. So here in the Elm work, so we can also play with the parameterization of the model with the temperature, top K, and the retrieval system. Llama Index has also a very good retrieval systems. I recommend you to take a look to them, okay? So jumping to the picture, we recommend to use prompting methodologies and prompting techniques in order to tackle these 3 issues. So in order to use, for better performance, to use guardrails, so we want to just establish a polite conversation, these kind of things. Also, the way we want to answer, which format, if we want to provide the PDFs, the URLs, or any other things. So this is the response synthesis. So Llama Index has its own prompts, but we recommend you to play with them because the user experience can be much better. And also we have Spanish, we have English, we have Catalan, so here with the prompting, just playing with that, you can have a very good performance. So now imagine the following scenario. So the rack is running, it's already running, it was pretty well, and we get a new document, a new batch of new documents, okay? All of them of the same kind. So once we get this new document, we want to put them into Llama index, and then we create the pipeline, the embeddings, the query engine, the metadata. So now it's time to evaluate it. So how can we be sure that this RAG with this document are gonna be good enough or fair enough? So in our situation, in order to ensure that the new release is gonna answer properly before we release it, we create a ground truth set of questions. It's not necessary to have too many, maybe 10 questions per or 3 questions per document, not too many. And all of them should be supervised by professionals. So we put a question, we put the expected answer, and now we put all these questions into the LLM, into the RAG system. We get the answer, and now we are ready to compare them and to score them, if possible, by using any other kind of metrics, semantic metrics, correctness, or any other. So now the thing, so if everything goes well, so we release this new version of the RAG system, and we are happy because it's gonna be, we can ensure that it's gonna answer really well. So but the question is, what happens if something goes not as we can expect? So, and that way, maybe we have to change something in the code, such as, for instance, we have to change slightly the prompts. And so, but if we change this prompt, maybe we can impact indirectly to the previous already delivered RAG systems. So maybe we can break something then. So in order to avoid that, we recommend the use of LLM as a judge. So this is a natural language-based criteria you can describe. So this is also an example from 1 to 5, a scoring rating system. And you put each question of the ground truth, an answer to the ground truth, to the judge. And the judge is gonna score it really, really good with natural-based understanding. Okay? So you put all the questions that you have in the ground truth, the ground truth from this batch of documents and the previous one, so it's going to increase every time. You annotate all the scores, and you can then create your own metrics. Okay, you can compute your statistic and your own thresholds. So that means if you have a mean or a mean threshold, a mean score, and a mean metric higher than 4, for instance, you can release it and be happy because it's not going to have a very drift in the evaluation.
Thank you. Now it's time to talk about the numbers. By numbers, I mean the estimated amount of money that we think we will spend on this use case yearly. So let's go. For that mission, I want to share with you 2 scenarios. The first one is the use case that we built in less than 2 months. And the baseline is, okay, our premises that we take into account to measure how we expect it to expand on this in this use case. So we have our assistant up 24 hours a day, 7 days a week. We had the conversational feature enabled, so we need to keep the chat history. And of course, we set up some premises such as, okay, we will have between 10 and 20% of our agents active. And it can send between 5 and 10 messages a day. So the stack of this first release was the Azure OpenAI, Azure Cognitive Search, Databricks, and Copilot Studio. And let's check what it was the first scenario. So it was oriented to our agents. We have 8,000 agents. And well, the estimated cost was between 140K and 160K. Okay, so just take in mind that the prices are decreasing, and this is our own thoughts on Santa Lucia, but I hope you can get something on that. And the majority of the budget goes to Databricks because of the serverless, and to Copilot Studio, which is the virtual chatbot that you remember, and is billed by number of messages. Let's imagine a future scenario if we can achieve the massive use case, which will be oriented towards our final clients. And let's say we have, among 1 million users. So what will happen with our architecture? So the annual cost will be more than 100 times the previous one. So you can imagine if we reach that number, we probably will get fired. So we need to do something to mitigate it. And you can imagine that the majority of the budget goes to Azure OpenAI and the same to Copilot Studio. So what we did is, we need to mitigate that. So for the Azure OpenAI one, if you remember, we are building an abstraction layer to allow our developers to interact with new open source models. So definitely we need to challenge GPT-4 with smaller open source models to reduce costs. And for Copilot Studio, if you remember again, we built the OCP microservices to replace the Copilot Studio, and it allows us to be more flexible deploying both in Microsoft Teams and Salesforce. So we got it. Now we need the sponsor of our business to achieve the massive use case. Okay, now we will share with you our roadmap, so we hope it can inspire you. Let's go. So we will focus now on doing fine-tuning both on retrieval and embeddings for two mainly reasons: to improve performance and to reduce costs. Of course, we will test new open source models. This is a fancy world where every week are coming up new models, so we will test it to challenge GPT-4, as I mentioned. We will enable new features, so we will collect the feedback of our agents so we can enrich the quality of our answers. Of course, we will include a link to the document and the section of the document. So in case our agents have some doubts on the answer that our chatbot get back, so they can manually check if it's okay or not okay. We put again the man on the loop to check the answers. And we will enrich with several data from our lakehouse. And of course, we will add more and more documents and databases. Okay, so as a recap of our journey from zero to this use case, remember we created something that can answer as well as a human, as well as an expert in coverages do. So Eduardo told us we reduced the false positives, we're working on it, so we built something that we are very proud of it. The time saved in every document search is a milestone. We reduced like 80% the time they spend looking for every document. We create definitely a RAG template. So we not only build an isolated pilot, we create something in production at enterprise level with all the security and all the CI/CD process and so on. We create the machine of machines to develop RAG systems with not a few clicks, but in a few days, sure. We will need to continue to improve both the performance, cost, and the accuracy of the answers, because if we want to achieve our goal to build something massive. And well, before finishing this presentation, we want to share with you some takeaways that we learned from the lesson of build a RAG at enterprise level. So first, as always, quick MVP. You need to show to your business as fast as possible, validate with them, iterate again and again. This is essential to success. Of course, you must grow at your own pace. I mean, every day I'm coming up, I'm launching new models, new frameworks, a lot of technology about Gen AI. But don't get obsessed. This is not a technology problem. This is a business problem. Focus on that. And of course, make the business case. You must measure both benefits and costs. And of course, impact your business. Thank you so much for your time. It was a pleasure to be here presenting in San Francisco. So